In this video, we're going to be going over a short summary of molecular compounds and ionic compounds. And this is our part 8 video inside of chemistry, chapter 2. So far inside of chapter 2, we covered mostly about binary compounds, molecular compounds, and ionic compounds. So that's why in this video, we're going to be going over a short summary of all of them. So first of all, for a summary between these two, there is a table here that summarizes naming conventions for molecular compounds and also ionic compounds. So for the first one, the difference between molecular and ionic. So inside of binary molecular compounds, they contain two nonmetal elements, and on the other hand, binary ionic compounds contain one metallic element and one non-metallic element. So we covered more about this inside of our previous videos, so you can go check that video out if you're interested. So this is the first difference. For the next one, we have the leftmost element on the periodic table is written first in the name and the formula. So this is for the molecular compounds. So for example, if we have carbon dioxide, so in this case we always put carbon first because carbon comes left of oxygen, so it's before oxygen, you can say. And on the other hand, for ionic compounds, the metallic element, which is the cation, always is named first. So you're never going to see an anion first. The anions are always behind the cations. So furthermore, in molecular compounds, these compounds are named using prefixes to indicate the number of atoms inside of each molecule. So for example, if you have P2O5, these P2 and O5, they just represent how many actual atoms are there. So P2 means that there's 2 phosphorus and O5 means that there is 5 oxygens. And on the other hand, for ionic, the name of the non-metallic element, which is the anion, is changed to IDE. So at the end of an anion, you're always going to see an IDE suffix most of the time. So for example, sodium chloride. So that's the naming prefixes of both of these. And then the prefix mono is omitted in the first element named. And an example of this can be carbon dioxide. So you're never going to say monocarbon dioxide. So whenever you have a name, you're always going to omit mono in the first element. And on the other hand, for ionic, cations with more than one possible charge are named using the Stock system. And this usually applies to transition metals. So if you see more than one possible charge, then you're going to name them using the Stock system. And for molecular compounds, subscripts and formulas of these compounds indicate the number of atoms in each molecule. For example, a molecule of CO2 contains 1 carbon atom and 2 oxygen atoms. And on the other hand, for ionic compounds, the total charge of anions and cations must equal to 0 in order for it to balance. And also, one more thing in ionic compounds. So ionic compounds with polyatomic ions, so you need to refer to the periodic table for names and charges of polyatomic ions, and you also treat a polyatomic ion as an actual unit or as a single charge. So this is a short summary of the differences between molecular and ionic compounds. And now we're going to be going over some questions and quizzes in order to check our understanding. So for the first question, we need to name the following ionic compounds. So for the first one, we have MgBr2. So in this case, we know that Br is going to end with a ATE or IDE suffix. And we already know what Mg is, magnesium, and we know what Br is, bromide. So for A, it's going to be magnesium bromide. And similarly, you can try out the rest of the questions for yourself. And also feel free to pause the video in order to try these out for yourself. And now we're going to be going into the solution so you can see if you're right or wrong. So for the first one, we have magnesium bromide. For the second one, which is KHSO4, we have potassium hydrogen sulfate. So you can see here that we don't have an IDE suffix since SO4 is always sulfate. So if you have SO4, anywhere if you have O4, then you're going to get 8 at the end, so ATE. And if you have 2, then you usually get IDE. So for example, in the first one we had bromide. In the second one we have potassium hydrogen sulfate. And for the third one we have phosphate, so ammonium phosphate. So NH4 is ammonium and then phosphate. And for the last one we have calcium hydroxide. So this was our first question. And moving on to the second, we need to name the following molecular compounds. So remember, in molecular compounds, we need to use the naming suffix and prefixes. So for example, if we have 2 oxygens, we need to say dioxide. So in this case, let's see. We have CF4. So C is obviously carbon and F is fluoride. So since we have 4 fluorides, we have to say tetra. So carbon tetrafluoride. So that's how you would say it. And for same thing as the previous slide, try these rest out for yourself. And we're going to go into the answer right now. So for the solution, for the first one, we have carbon tetrafluoride. For the second one, this is a little different compared to the rest. This has its own separate name, which is phosphine, but if you were to say inside of the actual formula, then it would be phosphorus trihydrogen. For the next one, we have PCl5, which is phosphorus pentachloride. For the letter D, we have N2F4, which is dinitrogen tetrafluoride. And finally, for the last one, we have oxygen difluoride. So now moving on to the next question, we need to identify each compound as if it's ionic or molecular, and then mark the binary compounds with an asterisk. So binary compounds is where there's two different elements that are combined together. So first of all, let's just see if these are ionic or molecular, and then we can decide if they're binary or not. So for the first one, we have P4O5. So if we look at our periodic table, if I just pull that up, so P, we know that it is phosphorus. So phosphorus is on the right side, which means that it's a nonmetal. And then we also have oxygen. And oxygen is also on the right side, which also means that it's a nonmetal. So since we have two nonmetals, then that means this is going to be a molecular compound. So we know this is a molecular compound, and this is going to be binary. And binary means that there is two different. So we can see that there is phosphorus and oxygen. So this is also going to be a binary compound. So in conclusion, this P4O5 is a binary molecular compound. And if we were to say the name, then it would be tetraphosphorus, and then 5, which would be pentaoxide. So now you can try all these rest for yourself, and we're going to go into the solution now. So for the first one, we have molecular, and for the name, we have tetraphosphorus pentoxide, and it is in an asterisk because it is a binary molecular compound. For the second one, it is ionic because one is a nonmetal, one is a metal. And then for the next one, we also have ionic, and it's potassium nitrate. And finally, for the last one, is also not ionic, and it's magnesium iodide. And this is in an asterisk, which means that it is a binary compound. So that summarizes everything for question number 3, and let's move on to question number 4, which is write the formula for each of the following compounds. So for the first one, we have phosphorus pentachloride. So all we need to do is write the compound. So we know that this is going to be a molecular compound because we're saying penta in it. So phosphorus, which is just P, and then since it's pentachloride, we know that there's 5 chlorides. So it'll be PCl5. And similarly, you can try out the rest for yourself, and we're just going to go into the solutions now. So we can see that the first one is PCl5. For the next one, sulfur hexafluoride. So sulfur is just S, and then since there's 6 fluorides, we say SF6. For the third one, we have nitrogen trifluoride. So nitrogen is just N, and then fluoride, there's 3 of them, so it's NF3. For the next one, we have silicon tetrafluoride. Silicon is just Si, and then there's 4 fluorines, so it'll be SiF4. Then we have silver phosphate. So in this case, you have to, since this is an ionic compound, we have to do a little bit of arranging inside the atoms. We need to look at the valence electrons so we can actually match them up and see how much we need. So in this case, we need 3 silver atoms and 4 phosphate atoms in order for this to work. For the next one, we have manganese, and then 2, which means that there's multiple cations, and then dichromate. So in this case, it is MnCr2O7. And for the next one, we have sodium perchlorate, and in this case, it is NaClO4. And for the last one, we have cobalt-3 permanganate, and in this case, the formula is CO, and then inside the bracket, MnO4, and outside is 3. So this summarizes question number 4. For question number 5, we need to write the systematic name for each of the following substances. And in this case, we can do both of them, so the common name and also the systematic name. So systematic name means like what scientists would call them, and then a common name is what normal people would call them. So H2O is obviously simple, it's just water. So it's water, or also dihydrogen monoxide if you were to say the systematic name. And for the same thing for the rest of them, NH3 is ammonia, which is the common name, or nitrogen trihydride. And then for the third one, we have potassium carbonate. For the fourth one, we have sodium hydroxide. And for question number 6, explain why a standard naming system is important for international communication, safety, and efficiency. And the reason why a standard naming system is crucial for several reasons, and for international communication is because it allows scientists from around the world to understand each other clearly without language barriers. So if everyone has the same thing, then all the scientists were going to know and they can understand each other clearly. And for safety, in the context of handling chemicals, it's important to know exactly what substances are being used to ensure proper handling. So this summarizes question number 6. And for some final words, we talked about molecular compounds, ionic compounds, and also how to name compounds. And for our upcoming content inside of chapter 2, we're going to talk about properties of substances. So that summarizes everything for this video, so thank you so much for watching from Try to Be Useful, and we'll see you guys in our next chemistry video.